Continuing with section 3.2, in the last video I showed you the formulas for the Malthusian model and the logistic model. So now we look at some examples. There is a table in your book in section 3.2 which gives you the census data and some more information about the population of the US. So we are getting information from that table and trying to do these problems. So an example says that in 1790 the population of the United States was 3.93 million, and in 1890 it was 62.98 million. First part, using the Malthusian model, find the US population as a function of time. So remember, in order to predict the complete model, we have to know two data values or 2-point values. So for example, here now we are given that in 1790. So we are starting at 1790, so we will take the t is equal to 0 at 1790. So we say in 1790 t is equal to 0 years, and the p naught, which will be equal to p of 0, is 3.93 million. So we will take p of 0 as 3.93. Plugging in the equation, we get p sub 0 is equal to 3.93, and that we can immediately plug in for the p naught in the formula. Here is the formula for the Malthusian. So p naught is 3.93. Then the second information or second data value in 1890. Well, it's 100 years later, so t is 100, and p is given to be 62.98 million. So plugging this p value, 62.98 equal to 3.93, so this should have been a 3, and let me make this correction. So this is 93, and then e to the k times 100. So now our job is to find k, and in order to find k, I have to manipulate the problem. I mean, we have to look at what we know from algebra, how to deal with it. So in this case, what you will do is, you have this situation, and you will now divide by 3.93 on both sides. So on left side I get 62.98 over 3.93. On the right side, when divided by 3.93, we get 1 here. So e to the 100k is left on the right side. And now we have to convert this into logarithmic form. So we get ln of the quantity on the left equals 100k. I hope you guys know how to get there. Now k will be equal to 1 over 100 times ln of this quantity, which gives you the value about 0.0277. So we plug it in the function, and that is our model, or that is our function in terms of t. So this is the Malthusian model. Now part B is saying, estimate the US population in 1900. Now in 1900, what will be the t? So if you say from 1790 to 1890, we have 100 years, and we have to add 10 in here. So 1900 will be 10 more years, so will be 110. So we now plug in 110 for t, and we get 82.73 million. So that is our answer for part B. Part C is saying, in addition, we know the population of the United States was 17.07 million in 1840. Using the, sorry, it should say using the logistic model. Give the US population as a function of t, and then we again estimate the population in 1900 in the next part. So for the logistic model, remember we have to have TA as TB such that TB is twice TA. So we have 1840. So we have to think about, okay, how much, what is T in 1840? So again, so 1790, then you add 10, so you get to 1800. So 1810, 1820, 1830, and 1840. This is our zero count. This is 10, 20, 30, 40, and then 50. So we have 10, t is equal to 50. So in 1840, t is equal to 50. So we now can take our t of A to be 50, t of B to be T of B to be 100, and T of 0 as 0. Then P naught we know is 3.93, and PB is 62.98, and PA is 17.07. So remember, this is the population at 50 years. This is the population at 100 years, and this is the population at 0 years. So now, using the equation 1 from problem 12, we get P1. So just plug in all the values, put it in your calculator, multiply everything, and we end up getting this value. This is our P sub 1. And now, using the second equation number 2 in problem 12, we find A. So again, plugging in the values, and we get A is equal to 0.00000012. Now we just plug it in the model, the logistic model, which is here. So plugging in everything, we end up getting the logistic model is looking like this. So note here now, here the only unknown thing is T. So now we can evaluate the population at any time T between, starting from 1790 to even to the present. So B part was that we have to now use this model to predict the population for 1900, and so everything stays the same. The only new thing that we are plugging in is 110 for T, and when you do, you get this population. And if you compare it with the population in 1900 in the given table, you will see that we are very close to that. So this is how you use the logistic model and the Malthusian model.